Okay, so how does it go? Low, right? Which is what? Okay, so low d high. What's d high? 2x. Minus high, which is? Right? Right, so low d high minus high d low, which is 2x. And then what do? Square the bottom, and away we go. Okay, so let's clean it up a little bit. So I need to distribute this 2x, right? And that'll give me what? 2x cubed plus 2x. What needs to be distributed here? A 2x and a minus sign. What do you think one of the most common mistakes is? Not distributing the minus sign. Okay? So that gives me minus 2x cubed plus 2x all over x squared plus 1 squared. There's no reason to expand that binomial in the denominator, by the way. So those go away, and I get 4x over x squared plus 1 squared. This is the derivative of this. What does that mean anyway? What have I just found? What is that?
It's how you find
This is the formula that would allow me to calculate the slope at any point on the graph of that function, right? Okay, so always keep in mind what it is that we're really doing. Yes?
If it was x squared minus 1 on the bottom, would it not be able to plug 1 in for the derivative equation?
Yes.
So like the limit to the original equation apply for the restrictions they apply?
Yeah, there would be. Okay, so I need to show you some other notations that you might see. So there's this mathematician named Leibniz. Okay, so he's got some notation that we see.
Wait, his last name is?
Yeah. No.
First name.
All right, and you'll see this in textbooks, and I just don't want it to freak you out if you do, okay? So this says find the derivative of u times v. What rule are we going to use? Product rule, right? We're not just going to do the derivative of u times the derivative of v, correct? Everyone nod your head. We're not going to do that, okay? So the product rule says that I do what? The first times the derivative of the second. So I'm going to write uv prime. First times derivative of the second. What sign? Plus. Right? Because it's product. Yes. V u prime. Right? First times derivative of the second plus the second times derivative of the first. Can any of that, can this be interchanged? Yes. Why? Because it's addition. Okay, good.
But non-subtraction, right?
Correct. So tell me how I would write the derivative of u divided by v in this same notation. V
times
u prime
minus u times v prime.
Yep. And then v can't be what? 0. Good. Okay, so dy dx would indicate the first derivative. This notation does not mean the derivative squared. This means the second derivative.
Is there any reason that the 2 is in front of the y behind the x?
There is. What do you think this is? It's the third derivative. There is, and it's really a discussion for later. It's not even next time. It's like way down the line.
Next season.
Okay, so let's do some higher order derivatives. Okay, so if I start with this, f of x is equal to x cubed minus 5x squared. Oops. F of x equals x cubed minus 5x squared. And I ask you to compute f prime of x. What will you tell me?
3x squared.
3x squared minus 10x. Okay, so everybody in the room should have been able to tell me that like that.
Yes.
Okay?
I wasn't sure.
Okay. Right, so f double prime of x. F double prime of x. What do you think that is?
6x minus
6x minus 10. Good. A little more participation. I like it.
Six.
What about f triple prime? 6.
Can you use Roman numerals?
Say again.
Can we use Roman numerals?
You can. You can use Roman numerals like this for the fourth derivative, and what would it be? 0. You might also just see it written like this with the 4. See that right there?
That's a little more.
Yeah, that's just a little 4. Okay, either way. Okay, and we talked about that picture yesterday, right? What these look like.
Yes.
Okay, let's talk about 2 more things before you go. The derivative of sine and cosine. Okay, so let's take a look at the graph of y equals sine x. Okay, I'll put it on the trig window. And there it is, right? We're all familiar with what sine x looks like, okay? So tell me about the derivative from here to here. The derivative isn't increasing. The function is increasing, so the derivative is positive, okay? The function is increasing, so the derivative is positive. Here the function is decreasing, so the derivative would be negative, right? Okay, so do you have any thoughts on what might happen? So these are positive, right? What's the derivative right there? 0. And then it goes how? Negative. What's the derivative there? 0. And then it goes positive, right? So we're like,
It's like the opposite.
okay? So it seems like it shifted, right?
Yes.
Okay, well, let's graph the derivative because we can. So I'll go math 8. And I'm going to tell it to graph the derivative of what's in y1 for all x. And let's see what that looks like.
Yes.
What is that? That's cosine, right? Isn't that cosine?
Yep.
Yeah. So the derivative of sine of x is cosine of x. That's pretty cool. Okay, so this dark one is cosine x, right? So what do you think about its derivative? Right here it's 0. Right here it's 0. What is it here? Negative. What is it here? Positive.
Like, you add a negative sign.
Let's see. So I can also tell my calculator to graph the derivative of what's in y2. Okay, so I'll go math 8. That your brain's going to blow up? Why?
Inception.
Okay, so now I'm going to graph the derivative of what I have entered in y2. By the way, your calculator will only do it 2 times. Then it'll tell you nesting error. It can't do it anymore. Nesting. Okay, so here we go. Ah.
What is this? Calculator's trying so hard.
The calculator's trying so hard.
Like, go right to
He's thinking so hard.
You already know how hard this is.
So Micah was right. What is it, Micah?
It's negative sine x.
It's negative sine x. Okay. So the derivative of cosine x is negative sine x. And you can kind of, I mean, by looking at the graphs, you can work your way through that, right? You can sort of rationalize that, work your way through it. We've confirmed it there by the graph. Okay, so these are the short rules for derivatives you're going to be working with in tonight's homework. Okay? And tonight's homework is still in that same derivative packet. And I expect you to be here with your homework done tomorrow. Okay?
Poor Gregory.
All right, so if you notice, the first page in that packet is actually page 115. So we'll do 19 through 23 odd and 39 through 51 odd. Remember, the answers are in the back. And then if you turn to the second page in the packet, you'll notice at the top it's a different page number. It's page 126. And we're going to do 1 through 11 odd. Okay. And I think we have a little bit of time. We do. We always finish so much faster in here than the other class. They do, and there's 21 of them, and right now there's 11 of y'all.
I really like this. It's pretty loud. Is Nick still in there?
Yeah. Yeah, they're pretty loud. I mean, it's okay. They're not bad or anything. They're just, it's just a little harder to move. Like, you guys don't talk very much at all.